Is related to something that you talked about in Algebra 1. In Algebra 1, you didn't talk about inverse variation, you talked about something called direct variation. And we'll review just really quickly what is direct variation and how can we tell if something has direct variation. And then we'll also talk about the inverse variation. So we're actually going to kind of look at both, but more focus in our book is going to be on the inverse variation because that will lead us into the main topic of chapter 7, which is rational functions. And we'll talk more about rational functions tomorrow when we get done with inverse variation. Okay. So the first thing we want to do is take some notes about direct versus inverse variation. Okay, so like I said, direct is something you should have seen in Algebra 1. The variables x and y vary directly if y divided by x is equal to a. Now what does that mean, y divided by x equals a? You could tell that things have direct variation if for any pair of x and y coordinates that belong to each other, if you divide them, and you can do y over x, you could also do x over y, okay? If they always equal the same value, which we're calling a. So I'm going to point to a and I'm going to say, this is my constant of variation. Constant of variation means a doesn't change for a particular set of points. That would mean I'd take every y over x, divide every y by every x, and they would all equal the same number. So like maybe y over x is equal to 10 every time. Then it's direct variation, okay? And 10 would be my constant of variation. Okay. The equation for direct variation looks like y equals a times x. So when you're looking and comparing x's and y's, if they divide to always be the same number, that is direct variation. But when you write out the equation, that means one variable is always getting multiplied by your constant. Okay? So I'm going to make a little note here. Constant is multiplied by a variable. So the constant a is getting multiplied by x, and then that's giving us y. It doesn't have to be the letters y and x. You know, if we're talking about a word problem, we could replace them. So we could say like p equals a times r. But since the constant of variation is getting multiplied by like a variable r, that would be a direct variation. And a is really going to be a number. So it could be y equals 10x, y equals 2x, y equals 1/3 x, y equals square root 2 times x. As long as there's a number getting multiplied by a variable, that represents direct variation. And it can also be switched around, like it could be x equals 3y. X equals 3y is still direct variation because the variable is getting multiplied by a constant. Okay. Now, on the other side of this, the variables x and y vary inversely if x times y equals a. Okay, so instead of taking every y and dividing it by x, if you take every y and multiply it by x, and you continually get the same number, a, then that would represent your constant of variation, and it would be an inverse variation. And if the x and y always multiply to be the same number, that means in the equation, your constant is getting divided by a variable. So instead of writing out an equation that looks like multiplication, which is direct, inverse variations always look like division. Now you have to be really careful with this equation. In order for it to be inverse variation, the constant must be divided by the variable. Which means the variable is in the denominator. If you have a variable in a numerator divided by a constant number, that is not inverse variation. Inverse variation requires that your constant be in the numerator and your variable be in the denominator. So the next piece that we're going to look at is I'm going to show you 4 different equations, and we're going to try to decide, are these 4 different equations examples of inverse, direct, or neither? Okay, so we're trying to identify if they show inverse variation, direct variation, or neither. Here's my first example. X equals 7 times y. Just real quick, like, what does your gut tell you? Just say what you think. Inverse, direct, or neither? I got one direct. Another direct. Why would you say, like, Faith, you answered direct pretty quickly. Why do you say direct? The number 7 is constant, right? It's always going to be 7. It's stuck there. And it's getting multiplied by a variable. So that should be direct. Is it okay that it's not y equals 7x? Yeah, it's totally fine. This is still an example of direct variation. Okay, because the constant is getting multiplied by a variable. If you wanted to make it look like y equals a times x, you could take x equals 7y, and you could try solving for y. What would you have to do to get y all by itself? Kylie says divide by 7, so we would divide both sides by 7. And then this is that one where I'm saying, like, you have to be tricky. That, or you have to be careful because it is tricky. If you rewrite that out as y equals x over 7, some people might say that looks like inverse variation because it looks like a fraction. But remember, in inverse variation, it's really important that you're dividing by the variable, so the variable has to be in the denominator. This one is really saying we have y equals 1/7 times x. That's the same thing as x divided by 7, is to multiply by a 1/7. So that still is an example of direct variation. It's just that it's getting multiplied by a fraction instead of a whole number. Okay. So be really careful and really conscious. You can only label something inverse if, when you solve for one variable, the constant is getting divided by the other variable. So the variable's in the denominator. Okay. Let's try another one. xy equals 3. xy equals 3. Jackson, you said, what did you say, inverse? Oh, so you're looking at that piece I gave you in the definition, right? Okay, so he's looking up here and he says, the variables x and y vary inversely if x times y equals a constant. Well, here we're saying x times y equals 3. So this is like x times y equals a. And when we go back into our notes, that's described as inverse variation. So it is inverse. That is correct. Now, if you immediately thought direct, I think that would be a normal thing. Why might a lot of people say direct immediately there? Because they see multiplication, right? They see x times y, oh, direct. But you have to be really careful. What you're looking for is the constant in a variable. Is the constant getting multiplied by a variable, or is the constant getting divided by a variable? So if you don't use the definition like Jackson did, then you would look at x, y equals 3, and you could like do what we did up here, which was solve for one of the variables. Maybe I'll solve for y, so I'll divide both sides by x, and now I have y equals 3 divided by x, which that puts the variable in the denominator, so that is in fact inverse. What about x equals 7 minus y? Do you think direct, inverse, or neither for 7 minus y equals x? Neither. Did I give you any rule for adding or subtracting? Nope. So neither. Good. Thank you, Eric. Going out on the limb there. If anything has a plus or minus, it's not considered inverse or direct variation. Okay, inverse or direct is simply a constant multiplied by a variable for direct, or a constant divided by a variable for inverse, nothing else. Okay. And the last one. Let's see if I can get this over here. Y over x equals 10. Is that direct, inverse, or neither? Take a minute just to think about it on your own. And then share with the people around you, shoulder buddies or small groups. Have a quick chat. Do you think that's direct, inverse, or neither? And try to justify why you think yours is what you say it is. Okay, go ahead and do that now. What did we say, inverse or direct there? I hear direct. Okay, it is direct. There's two ways to go about it. You could use like the definition piece that I wrote down. Two variables, x and y, vary directly if y over x is equal to 10. But this one is x over y, and I had said it doesn't matter what order the variables are, right? If you're dividing two variables and it equals the same thing. The other thing you could do is, just like we did on the other two, solve for one of the variables. In this case, instead of solving for y, I might just solve for x, because I want to multiply both sides by y, and that will get me x equals 10y. Well, that very clearly looks like a direct variation. And again, is it okay, like on this first one, that it was x equals a times y instead of y equals a times x? Yeah, it's fine. If we solve it the other way, it would be y equals 1/10 times x. But that's still a direct variation. So these will be proof to you that, like, it doesn't matter what way you write it, it'll still work out the same way. Okay, so I mean, it will give you different a values, but like your x and y's will still work out to be the same x and y's. Okay, depending on how you write it. Okay, moving along, there are some other examples where we can tell whether it's direct, inverse, or neither. Let's say I give you a table of values. Okay. So here I tell you x is -4, -3, -2, -1. And then I tell you y is 20, 15, 10, and 5. If I'm presented with a table of values, the best thing I can do is think back to those definitions of direct and inverse. If it's direct variation, y over x equals a constant. If it's inverse variation, x times y equals a constant. And then if neither of those things happen, we would label it as neither. So what I would do presented with this table is I would start with one of these and check. So like I might start with direct variation. I'm going to check my y's divided by x's. 20 divided by -4 is -5. 15 divided by -3 is -5. 10 divided by -2 is -5. You think we're on to something here? Yeah. 5 divided by -1 is -5. Since they all came out to be -5, that means y over x equals a constant. So that's what type of variation? Direct. And if you take the time to check for direct, you could very easily write an equation relating these two values, because you now know that a is equal to -5, so y equals -5 times x. And think about that. If I took -5 times x and plugged in all these x's, -5 times -4 is 20. -5 times -3 is 15. Okay, so it works. You don't have to do this writing of the equation on this problem, but just to show you, like, it follows really nicely. Can you check this table? And some of you will write things down, and some of you might check it in your head or in your calculators, that either is acceptable. Is this direct, inverse, or neither? So take a minute to look at that. Talk to the people around you. What'd you say and why? Is it direct, inverse, or neither? Lauren, what'd you guys say? What'd you say?
I was still trying to figure it out.
Oh, you're still trying to figure it out. Sierra, what'd you guys say?
We said inverse.
And what's your guys' reasoning?
We just plugged it in, so we did 1 times 60, and it equals 60, and then 2 times 30, and that equals 60, and then so on.
Yeah. Did anybody in your group check inverse? Did anybody check direct first? Yeah. Sometimes you might just be able to look at the numbers and you see, like, oh, they're not going to multiply to be the same thing. But Sierra's explanation is great. They just multiplied them all together, the x and the y's, and when x and y equals the same thing, or x times y equals the same thing, then it's got to be inverse variation. You could have started by checking for direct variation like we did on the first one, and you'd start by saying, like, 60 divided by 1 is 60, and then you'd go to the next one, and as soon as you got to 30 divided by 2, not constant, right? If one divides to be 60 and one divides to be 15, It's not direct variation. Okay? So you might not always know right away, but really, these are the only two things you have to check in a table. Okay, so multiply the x's and y's, divide the x's and y's, and then be able to say which one it is if you get a constant. Here is another type of question that you'll be asked on your homework today. The variables x and y vary inversely. Use the given values to write an equation relating x and y. Then find y when x equals 5. So this is how I approach a problem like this. First, there's a sentence there that tells me what equation to use. Okay? The variables x and y vary inversely. So I think back, what's the equation for inverse variation? Y equals a over x. It won't matter if you write y equals a over x or if you write x equals a over y. Either is acceptable. You will get different a values for those two equations, but both will work and be valid. Okay, so it'll just be different depending on what you plug in. How do you think, after you know that it's supposed to look like y equals a over x, what are some options you could do? There's multiple ways to do this, to use the given values to write an equation relating the x and y. What are you guys thinking about possibly doing? Why would you multiply 7 and negative 3? Okay, if you know that it varies inversely, our final equation should look like y equals a over x. And we also know that x times y equals a, which is our constant, right? So Jackson says to find the constant, do x times y equals a, we'll do 7 times negative 3 equals a, so a equals negative 21. This is my constant of variation. Now I just need to plug it in. And that will give me my equation that relates x and y. So I would have something like y equals negative 21 over x. If you're writing an equation to relate x and y need to be left as variables. Okay, so we want to plug in for a, we want to leave x and y alone. That's a great method to use. It's using the definitions that you know x times y equals a. Did anybody else think about doing something different to find a? On a side note, okay, if you want to use Jackson's method, that works perfect. On a side note, you could also do this. If y equals a over x, and you know that x is 7 and y is negative 3, you could plug those numbers in, and then you would multiply both sides by 7, and you would find out that a is negative 21. So we get the same answer either way. And then how will we find y when x equals 5? Simply plug it in. So when x equals 5, y equals negative 21 over 5. If you want to put that into a calculator and get a decimal, I think it would be negative 4.2. Yeah. You can do that if you want to leave it as the improper fraction, negative 21 over 5. That's fine. Those are your two answers. Okay. I'm going to give you one to try. So I want you to write your own equation, and then for you to solve for the value of y. Okay. And I got to change this. Find. Oops. Okay, the variables x and y vary inversely. Use the given values to write the equation relating x and y. And I'm changing my tone slightly there. Find y when x equals 2. Okay, so I'm going to give you some time to work this out. Okay, on this one, sort of the same idea. I noticed that we're varying inversely, so I'm going to get started by writing y equals a over x. That's what I want my final equation to look like, because it's an inverse variation. If we're using Jackson's method, we need to find the value of a, and we know in inverse variation that x times y is equal to a. So we can just do 3 halves times 5, which gives us 15 halves, or you could say 7.5, which I saw quite a bit of as I walked around. This cannot be your final answer. You have to take this and you have to plug that back in. So we might write y equals 7.5 over x, and now we have an equation relating x and y. So that I could ask Faith, what is y when x is 1? I can ask Bailey, what is y when x is 2? I can ask Riley, what is y when x is 100? Right? I can ask any question about x, because we have that equation. Find y when x equals 2. Y equals 7.5 divided by 2. Is that 3.25?
3.75.
3.75. Oh yeah, 3.5 plus 5. You're right. 3.75. So we have our equation, and then we have our value when x equals 2. So I've answered both of those. To get started on that problem, you have to decide, like, do you want your final answer to look like y equals a times x, or do you want your final answer to look like y equals a divided by x? And then job number 1, find a. Okay. Okay, last thing that we want to talk about just really quickly is a word problem. Okay, so that there's like, I think 1 or 2 at the end of the homework assignment. What you need to do is you need to do just like we did on those other ones. Read, it will tell you an equation. You just have to read and decide what letters they want you to use. It will be something like y equals a times x or y equals a over x. Except for it might not be in terms of y and x. It says, the time t in hours that it takes a group of roofers to roof a house varies inversely with the number n of roofers. It takes a group of 4 roofers 9 hours to roof a house. Write an equation to represent the inverse relation. Okay, so what I would start off with is the time t that it takes a group of roofers to roof a house varies inversely with the number n of roofers. So t and n vary inversely. Instead of writing y equals a over x, I'll write t equals a over n. I'm just using a different set of letters for x and y. Time represents t and n is number of roofers. They also give me information that will allow me to solve for my constant. It takes 4 roofers 9 hours. So I know to put 9 in for t and 4 in for n. So a is equal to 36. Or you could use Jackson's method where we say a is equal to r times n. Same thing, 36. And so my equation is t equals 36 divided by n. The thing that's nice about using the variables provided in the word problem or changing from just x and y is it's a little bit easier for us. Like if I say, what if the number of roofers is 10? Then we know to put that in for n. Whereas if we leave them as x and y, somewhere separately we have to label what x and y represent. X is the number of roofers, y is the time it takes. Okay, using a well-selected variable might aid in the understanding of that equation. What happens to the time it takes to roof your house as the number of roofers increases? It decreases, right? One guy would take 36 hours. 2 guys will take 18 hours. 3 guys will take 12 hours. So inverse variation is a relationship where as one variable increases, the other variable decreases. Okay? And they have a constant of variation that is x times y. Here's your homework assignment.